couple notes before we get started. Please make sure you read through this section first. It starts on 347 in your old book or volume 2. And I want you to read and fill everything out until page 350. So your turns 8 and 9 are the last places you need to go. If you read and get everything filled out without using this video, then that's perfectly fine. You don't have to watch it. Just make sure all of that is done and ready for class tomorrow. The next thing you need to know is that once you read through, if you're watching a video and you're not sure or the video is going too fast, don't be afraid to hit the pause button. Don't be afraid to use the rewind if you need to go back and forth, all right? That's what this video is here for your speed entirely, okay? The next thing I need you to do is grab a blank piece of paper and make sure you're ready to take notes, all right? This paper is going to be our foldable, so you can go ahead and fold that in half, all right? We're going to make the rest of it tomorrow, but this will be the first page. And then open it up, and on the inside, we're going to take some definitions. And I'll let you know what definitions we're going to take through using an asterisk. Wow. So let's go ahead and get our first definition. All right, it's going to be quantitative data here. We want to get that right at the top of our foldable. And it's going to mean numerical measurements. Measurements that you can actually make using an instrument, right? It goes back to that precision, and remember when we did significant figures in the beginning of the year. The second definition that we want to get down is categorical data. And for definition of categorical data, you can say quality data. That's not quality as in good, it's quality as, more immeasurable, more descriptive. And we're going to describe most of this data through counting it, or frequencies. So moving right along, we can take a look at our first example, and it says, circle the categorical data variable. So we have temperature, weight, height, color. For temperature, I think immediately, 32 degrees. That seems like something I can measure and represent as a number. And then we have weight, and certainly that can be expressed as a number that we can measure with a scale. And height, we can measure that with rulers. We're all aware that these have numbers. And then, of course, we get color, and all we can think of is purple. And if we were to poll the class, we would have all sorts of categorical data about who has a favorite color. But it's not necessarily anything that we can measure, just maybe count, right? So the next question, B here, says identify whether given data is categorical or quantitative. All right. Large, medium, or small? Well, that actually sounds like the quality of something, right? Or qualities of something. So that's probably going to be categorical data, whereas 100 feet, 120 feet, 130 feet, 140 feet, of course, is going to be quantitative data. Next, we're going to get two new foldable terms. The first one is set, right here. All right, and this set is a group of numbers. Get that down for you to copy down. Group of numbers represented with brackets. Brackets are these crazy things, and we separate the numbers with commas. This might look familiar because we've seen solution sets to quadratic equations like x squared minus 1 equals 0. We know that the solution set is -1 and +1. That's a set that we've seen in the past. Here we're talking about a different type of set. We're talking about a frequency table, which shows items that occur in sets. So groups of numbers. And right away we're given this example of ways students get to school. This is in fact a set right here. Get out my handy dandy lightsaber. Yep, sound effects. This is a set, and then we're going to show some more sets over here for each specific item. Right. So it says we've got bus, car, walk. All right, ways students get to school. Bus. There's 8 of them. We can go through and count. 1 bus, 2 bus, 3 bus, 4 bus, 5 bus, 6 bus, 7 bus, 8 bus. Great. How many cars are there? Well, let's count these together. There's 1 car, 2 car, 3 car, 4 car, 5 car, 6 car, 7 car. Awesome. And then there's this line for us to fill in. Well, happen to notice that there's some walkers as well. And when I count the walkers, I get 5. So let's take a look at the questions that they ask us about this. Notice that I have a set for buses. I counted 8. A set for cars, I counted 7. And a set for walkers, I counted 5. Each thing's that I can't really, obviously there's ways to measure a bus, but it's not anything specific about the bus. It's just buses in general. So there's no measurement there. It's just counting. The frequency of which I counted is the set. So how did I determine the numbers for each category in the frequency column? Well, of course, I counted the frequency. Counted how many? 2, what must be true about the sum of the frequencies in the frequency table? Well, it probably equals the total set of the ways to get to school, right? So if we add up 8 plus 7 plus 5, we're going to get 20. And if I count the number of ways that I can get to school, I also get 20. So all of these would equal 20 in here, which makes sense. And I should also recognize that that is the number of students total. So sum of items Next, I flipped over to page 348. We're going to be constructing two-way frequency tables. So a two-way frequency table is 2 categorical variables you can list in the frequencies of the paired values. Okay. Notice that I'm comparing grades of students now to their preferred fruit. Right? And we're going to be able to total these things up. So if I look across, the total 9th graders can be determined by how many likes each fruit, right? And that, of course, is 54. And the total 10th graders can be determined by totaling them up, and that's 54. I'm sorry, 46. And from here, we can see all our math. Don't put that in your foldable, I just made a note. All right, I can see the math there, and I can see the math coming down. All right, I can add these up to get totals. So let's take a look at our first example at the bottom, example B. Jenna asked some randomly selected students, note that it doesn't tell us which, whether they preferred cats or dogs or other pets. She recorded the gender of each student. The results are shown in the two-way frequency table below. Each entry is the frequency of the students who preferred a certain pet and are a certain gender. For instance, 8 girls preferred dogs as pets. Complete the table. So if we're looking at girls here, we note that we have 8 and 7 and 1, and that's a sum of 16. So I can put 16 over here because I went across the girls table. Then I'm looking at boys. 10 plus 5 plus 9, that's 24. And if I'm looking across the boys table, I can put 24 there. Column totals. So how many people like a dog? 8 and 10, that's 18. Of course, a column goes down, so I could put 18 in here. And then cats, 7 and 5, I've got 12. Of course, that's the cat column. And then other, I've got 1 and 9 for 10. Now let's look at the sum of rows in total. Again, I've got my total row. I have 16 plus 24. That gives me 40. And if I have 40 there, I should have 40 coming across in my rows. All right, so 18 plus 12 plus 10 equals 40. This is a good check to make sure you're getting everything correct. Make sure that everything lines up when you do your math. Let's flick to the next page. Top of 349. We get a couple questions. Look at the totals for each row. Was Jenna's survey evenly distributed among boys and girls? Evenly? Was that even? No, there were way more girls than boys. So, statistically speaking, not even, right? Look at the totals for each column. Which pet is preferred by most students? Of course, dogs got more than cats or others, so they were the most popular. Now I want you to take a second and complete the year turns. That's 5 and 6. We'll talk about these tomorrow, and these are what I will check for homework. I'll meet up with you. You can pause the video, and when you play again, we're going to be doing Explain 2, and we're going to pick right back up on page 350. So here we are on page 350, and we're given another table. And this time there's blanks outside of the total, right? We don't know how many girls liked milk in this. So let's read the problem. It says 100 students. That's going to be important. There's 100 total. Were surveyed about which beverages they chose at lunch. Some of the results are shown in the two-way frequency table. So the first thing that I absolutely know is that there were 100 total students. So I have 100 here, 60 there. If I'm looking for girls, and I know I've got 60 boys and 100 total, that means I'm going to get 40 girls. And that's going that way. Notice that I subtracted. Makes sense. Total minus boys equals girls. So the total number of girls is 40. The total number of girls who do not choose milk is 10 and 17, which is 27. And if all the girls are 40 minus the 27, that gives us 13. So I'm using subtraction to work my way backwards to find the missing frequency or data set. In this case, it's a specific data set of girls who like chocolate or like milk. From here, I want to fill in the rest of the totals, and I can check my work by making sure that it adds up to 100, but I'm going to add down. It's 25. That's 37, and that's 38. When I add those up, 25 plus 37 plus 38, 37 plus 38 is 75, plus 25 is 100. So that checks out. Which lunch beverage is least preferred? Of course, juice at 25 ranks less than milk, which ranks less than water. That's going to wrap up our video for today. Make sure you finish up the last two year turns, 8 and 9, and then stop there on page 350. Thanks again, guys, and I will see you next time.